Well, good afternoon, everybody. You're all very welcome. My name is Declan Fitzmaurice. I chair the technical committee for the Institute of Refrigeration Ireland, and this is the second in our series of webinars on the EN378 review process, which is going to public inquiry from July to September this year. So the Institute very much hopes that the industry in Ireland, contractors and installers in particular, will participate. So we're running these webinars to give people a heads up on what's coming down the line and improve familiarity with the existing 2016 version of the standard, which in itself is quite chunky. So the talk we have today is by Margaret Rafter, sales consultant with Mitsubishi Electric. She's going to speak about the risk assessment process and charge limit calculation process that's in EN378, in particular for R32 in air conditioning applications. It's a commercial presentation, so it covers Mitsubishi products, but also it covers EN378 in general. The IRI doesn't endorse or promote any one particular product over any other. So it's the EN378 part of this that we're most interested in today. So Margaret will go through the presentation, and if it'll just take half an hour. If we've time at the end for Q&A, please just type them into the Q&A link at the top of the page. And just before we hand over to Margaret, just thank all our corporate partners who helped to make all this possible, which is fantastic. And just to confirm, Margaret happens to be on the council and president at the moment, but she just has her Mitsubishi sales consultant hat on today. So feel free to get some questions in at the end on the webinar. Thank you very much, and over to you, Margaret.
Declan, thank you so much, and thank you, Karen, as well, and the technical committee for pulling this together. It's a really good initiative, and as Declan said, this is put out to all our corporate partners. So if you do want to get involved, please do reach out. Knowledge is power, and we need to arm ourselves with as much information as we can from everyone in the industry, not just ourselves. So I am going to talk today about R32, okay, and what is driving us currently to use R32. The legislation around that, so the guideline according to EN378. We'll have a look at some practical examples and calculations, and then I will also look at the safety measures that are allowed through using the EN378 with the application of R32. Okay, so hopefully you'll come away with understanding the R32 concentration levels, how to use that graph that's in EN378. How to understand the different room definitions, and also to see what safety measures you can offer if you are above the concentration level thresholds that are within EN378. So we've 30 minutes. I'm going to try and get through as much as I can. And as Declan said, we'll have questions at the end as well. So if you do have questions, please do reach out. It's no problem at all. So why R32? So our current climate, okay, is what's driving us towards the use of low GWP refrigerants, okay? So with the increased awareness and the need for more sustainable projects and products within the built environment, installers, designers, consultants, contractors, we need to be looking at HVAC technology that delivers energy efficient and low carbon solutions, okay? So we also need to be looking at the refrigerants that we use within our air conditioning and refrigeration systems, okay? HFCs are a huge contributor to global warming, okay? And the climate crisis that we're currently facing. So one of the quickest ways that we can try and reduce that impact is to try and phase out the HFCs, okay? And that's essentially what F-gas regulations are doing, okay? They're pushing us towards using lower global warming potential refrigerants, okay? And R32, which what we currently have available on the market, it's F-gas compliant, and it gives us that balance of using a low GWP refrigerant that is currently compliant with the current F-gas regulations, but also offers that high efficiency and that transfer, that efficient transfer that we need with a refrigerant and with a gas, So what are the benefits of R32? Well, the GWP is probably the biggest benefit. So compared to 410A, the GWP of R32 is 675. And the GWP of 410A is 2088. Now, not only that, R32 has 32% of the CO2 ton equivalent of 410A. So simply by swapping from 410A to an R32 system, you're already improving your carbon footprint and you're already reducing that CO2 ton equivalent. R32, it's environmentally friendly, okay? So it's non-toxic as opposed to 410A, which had a high toxicity level, okay? It is currently F-gas phase down compliant. So systems that are less than 12 kilowatts, okay, have to have a GWP of less than 150, okay, by 2029, okay? So that rules out R32, okay? And you are going to see systems less than or equal to 12 kilowatts coming down the line with alternative refrigerants such as, well, propane and R290 and that. For larger systems, okay, so your VRF systems and your bigger split systems, okay, so bigger than 12 kilowatts, you're allowed to have a GWP of up to 750 up until 2033. So R32 is fully F-gas phase down compliant at the minute, and it brings us up to 2033 as well, you know. It does offer longer pipe runs and it is efficient. It is a single component as opposed to a dual component, which makes it easier to reuse and recycle, and it's easier to handle because it doesn't separate. It utilizes familiar technology, keeping costs similar, and is relatively inexpensive to produce. It is non-toxic, it is difficult to ignite, and it does not explode. Now, in saying all that, it is an A2L, okay? And it is classified as mildly flammable, okay? And because of that, when using R32 refrigerant, it is necessary to take additional measures into account when planning and installing air conditioning systems. And the guidelines that you need to look at is EN378, which Declan went into, I suppose, more detail last week. And then IEC, which is 60335-2-40, and that's the product standard, okay? So we're going to focus more on EN378 today. But just to explain again, briefly for those of you who weren't online and who aren't familiar with the standard, it's a European safety standard, and its purpose is to avoid hazards to persons, property, and the environment from refrigerants that we use in our air conditioning and our refrigeration systems. It covers design, construction, installation, operation, and maintenance and disposal of refrigerant systems. You then also have IEC 60335-2-40, and that's the international product standard, okay? So that relates to the products, okay, that carry R32 and use R32. It's the international standard, and its purpose is to ensure safety of electric heat pumps and air conditioners. And it covers both electrical and refrigerant safety in multiple annexes, okay? But the key aspect of both of these is to manage your concentration levels, okay? The thing that you need to remember about R32 is that it's heavier than air, okay? So that it sinks, all right? And what we want to avoid is that being able to leak from a system and pool so that it could become a hazard, okay? We want to mitigate that flammability hazard from the refrigerant, you know? And ways that we can do that is by managing your concentration levels, okay? Now, within EN378, okay, when you have a project and you're using R32, what you need to first look at is its application, okay? And then you look at your refrigerant volume and the type of room it's serving and the concentration levels. But before you do that, the best thing to do is to look at EN378, okay? So EN378 has different categories of occupied spaces, okay? So the first one is general access A. And that's where sleeping facilities are provided, where people are restricted in their movement, where it's an uncontrolled number of people that are present, and where anyone can access any part of the building without being personally acquainted with the necessary safety precautions of the equipment that might be in that building, okay? So hospitals, courts, leisure centres, retail, education, restaurants, hotels. So that's general access A. And then you have supervised access B, okay? And that's where only a limited number of people may be assembled. And some might be necessarily acquainted with the general safety precautions of the establishment, okay? So that's your professional offices, your labs, and your industrial workspaces. And then we have authorized access, okay? And this is particularly important, okay? So authorized access C is where only authorized persons have access. So people who are acquainted with general and special safety precautions of the establishment, okay? So your comms rooms, your riser cupboards, your dedicated plant rooms, your linen cupboards, and locked rooms within buildings, okay? So it's only where authorized access personnel can access that room, okay? And this becomes important when you look at when you have to apply your concentration level calculations, okay? And just to remind you guys as well, as Declan said, the version that I'm looking at today, EN378, is version 2016, okay, which is the current version, all right? And that is currently under review. And it is going to go out to a public consultation. And everyone's going to have the opportunity to look at EN378 and look at how it's going to be changed. And some of what's here now could very well change in the next issue. But this is the current EN378 that I am referring to today. So within the current EN378, there's 4 types of refrigerating systems that could be used within a building. Now, they're classified as class 1, 2, 3, and 4. Now, typically in the air conditioning world anyway, we tend to stay within class 1 and class 2, okay? So that's your splits and your VRF systems, okay? Potentially you could have your outdoor unit installed internally if you have a water-based system. And then class 2, you have your compressed air and open air. So your splits and your VRF systems, okay? And basically what this is guiding us towards is being able to use this graph here, okay? So on the left-hand side, you have your categories of occupied space, and then you have your system classification on the right-hand side, okay? So in order to determine if we need to do refrigerant charge concentration calculations required, you need to know what system classification it is, but you also need to know what your occupied space is. So if I was to look at this, you could utilize this, right, and say authorized access C, so less than 1 person per 10 meters squared. And we're going to look at system classification 2, and so like a VRF system or a DX split system where the outdoor unit is outside. If it's in authorized access C, this stipulates that no refrigerant charge concentration calculation is required. So if you have a comms room that is authorized access, this is saying you don't need to do a refrigerant charge concentration calculation. But it is saying if you have general access A or supervised access B, then you do need to do your refrigerant charge concentration calculation. And it's our responsibility that we should be doing that. You know, it is for human safety. It's for the people that are in that space that we need to keep safe. You know, so it is our responsibility for us to check that and to do the due diligence and to do that risk assessment, you know. So what are the concentration calculations, okay? So the calculation, so EN378, it uses 2 safety thresholds, okay, to manage R32 refrigerant concentration, okay, in kilograms per meters cubed, and that's in occupied spaces. So the first is your practical limit, okay, your practical limit refrigeration concentration limit, okay, and that's 0.061 kilograms per meters cubed. Your second is your quantity limit, okay, with additional ventilation, okay, your QLAV, and that's 0.15 kilograms per meters cubed. Now, EN378 does allow you that if you do go above those safety thresholds, there is protective measures that we can put into place and which will allow us to install that equipment, okay, in a safe manner, right? And the safety measures that are available are leak detection with alarm, with audio and visual. And so it has to have an audio alarm and a visual light or device with an independent power supply. And that's one safety measure, okay? You then have mechanical ventilation. That mechanical ventilation needs to be operated continuously or activated by a leak detection at 45.5 liters per second. So, you know, it can't be an open window or anything like that you need to open it in the event of a leak. Safety shut-off valves, which must be located on the refrigerant pipework between the outdoor unit and the indoor unit, or outdoor unit and branch controller, or hybrid branch controller. And then passive ventilation, which is your transfer openings from the room to the outside or to a larger indoor space, okay? So you can have natural or mechanical ventilation, all right? So leak detection with alarm, mechanical or natural ventilation, and safety shut-off valves are your safety measures that you can put into place if you are above those safety thresholds, okay, for the use of R32. Now, Mitsubishi Electric has a tool to calculate this out for you and to tell you if and when and how many safety measures you may need. And so I'm going to go through that today, but as Declan said, you know, the IRI, I suppose, doesn't only promote the use of one manufacturer over another. Okay, so other manufacturers do have their tools. So we do recommend that you do go to all manufacturers and I suppose all locations where you can get this information. But this is a handy tool that I use myself when I need to do my due diligence and when I do need to do checks. Okay, so basically what that does is, instead of me doing these calculations, you know, on a piece of paper, this does it for me, okay? And it basically reviews the volume of refrigerant and it looks at the ratio of the volume of refrigerant and the area of the space that room is going to be serving, okay? So it looks at the concentration level and it tells me then if I need a safety measure and if so, whether I need a single safety measure or two safety measures, okay? That's based on the volume of refrigerant and the size of the space. So I think we're doing okay for time. I'm probably flying through it, but I'm going to do a couple of examples here. So once you click in to the risk management for occupied rooms, it's some general notes there, some terms and conditions that you need to agree with. You then click into EN378, which is the standard that we're going to be checking and focusing on today. As I said, this is a Mitsubishi Electric tool, so it does look at the Mitsubishi Electric products. But basically what you need to think of is you need to consider the equipment that you're using and the space that you're serving, okay? So if I was to look at, say, a VRF system, okay? So VRF system, you have your outdoor unit, you have your branch controller, and you have your indoor units, and you have simultaneous heating and cooling, okay? Most people know what a VRF system is, but you have refrigerant going throughout the entire system, okay? So you're going to have refrigerant in your occupied spaces, right? So you'll have one or 4 or more units, or 1, 2, or 3 internal units off that system, okay? Your units, your wall mount units, your ducted, your cassette, they'll all need to be installed at a height of 1.8 meters from the ground. So if I was looking at a wall mounted unit, it's typically 1.8 meters. If you're looking at a cassette or ducted, it can be anything above that, up to 2.2 meters high. So I'm going to put in 1.8 meters just as an example. The refrigerant that we're focused on is R32. The refrigerant quantity, you need to ensure that the refrigerant quantity that you input here is the refrigerant quantity with your pipe runs, okay? So it's not just looking at your outdoor unit or your single system. You have to have your pipe runs included. It needs to be the total volume of refrigerant that's going to be in that system that's going to be installed. And so make sure that you have that installed and calculate before you do this check. So say if we had 16 kilograms, small VRF, say 20 kilowatt system of R32, it then asks the installation location. So if it's a rectangular room or if it's a non-rectangular room. So we're looking at a typical office or a typical meeting room. I'll put in an area of say if it's like I don't know, a small open plan office, let's say 50 meters squared. Your height again is where the unit is going to be mounted. and then click next, and then click calculate. It should calculate it out for us. And then it shows you the calculation, okay? So what's important on this slide here, okay, is your graph on the right-hand side here, and then the measures that it's specifying you to take, okay? So because of the volume of refrigerant and the area of that room, it's telling us that we will need 2 safety measures, okay? And the reason it's saying that is, you'll see it's pinpointed here on the graph where we are. So if you look, zone 1 in green means no safety precautions are required. If you look at zone 2, it's at least 1 safety measure is required, which is the yellow area. But we're borderline on the red here. So it's telling us we need zone 3, which is 2 safety measures. The safety measures, as I mentioned earlier, can be leak detection with alarm, which is a single measure. It could be ventilation, which is natural or mechanical. And it could be safety shut-off valves, okay, which can be in use with an automatic pump-down system, so that in the event of a leak, the refrigerant is automatically pumped out to the outdoor unit. If you are using that type of system, you need actuated ball valves on the high and low pressure side of your refrigerant piping, okay? Mitsubishi Electric can provide that, as I'm sure other third parties and other manufacturers can. It just needs to be selected and sized correctly, you know. But as well as this, when you're working with contractors or installers or end users or consultants, they want to see these calculations. And this is a really handy tool to allow you, because it can print that calculation. So if I was to say test IRI meeting room, I can save that as a PDF and save that into my file. It will save it into your project file, and it will allow you then to go back and explain to the installer or, you know, the end user why you're putting in these safety measures. You can actually then do other selections then for different rooms within the building. And it will tell you when you don't need leak detection either. If I was to go back again, and I'll do another example looking at a split system. In our split systems, you probably have a lot less refrigerant in it, you know, depending on the split and your pipe runs, of course. But if you're looking at a simple wall-mounted split system with R32 and a refrigerant quantity of, say, like 3 or 4 kilograms of refrigerant, and say a room of 15 meters squared, it will tell you if you don't need leak detection either. So if you're just doing a safety check for peace of mind and you've already told them, look, based on the refrigerant charge in these rooms, you're not going to need it. If they're looking for, let's say, proof, you know what I mean, or something to back you up, you can do this calculation and it will tell you. So no risk management is necessary. So we've not exceeded any of the safety thresholds, right, in this instance. The small amount of refrigerant that could potentially leak into that space, because the space is so big, it's not going to be harmful and it's not going to be a hazard. Again, you can print it and save it to your project file as well. So it's a really handy tool. It is in my presentation. So you can download it, and it will, I think, be available on the IRI website. But if you do have any more questions on that, please do reach out. It's a handy tool to use if you're not familiar with the EN378 as well. It's very user friendly. So what are the safety measures that Mitsubishi Electric can provide? Obviously, other manufacturers and other third parties also have leak detection. They can provide ventilation and they can provide safety shut-off valves. This is just to show you what Mitsubishi Electric has, okay? And I suppose in terms of leak detection, okay, any type of detector may be used with a sensitivity of 77 grams of R32 per meters cubed, okay? And that's directly from EN378, Part 3, Section 9.3.2. All air leak detection solutions comply to this requirement, as I'm sure the other leak detection that are out there in the market do as well, you know. So 2 main types of refrigerant leak detectors that we provide are semiconductor and infrared, okay? They can both be standalone and they can be both used as a group. So you can have a standalone sensor in the room, or you can have them wired back to a common alarm panel. And that common alarm panel can be located with the service manager or the management of the building. And if they need to see, if there's multiple different leak detection sensors around the building, they might need to see where that leak is. So it's ideal. They must have audible and visual alarms built into the leak detection sensor. And it is considered one safety measure as per EN378. So looking at the semiconductor type first, okay? So the semiconductor type, it is a low cost option. It's an easy install. It's a good value solution for offices and high-end residential, but it can set off false alarms, okay? And so we wouldn't recommend it for hotels or student dwellings. You can use it, of course, but it can potentially set off false alarms. You know, how it works is basically a voltage change. If there's a reduction of oxygen, that changes the voltage, okay, through the device, and that voltage change gives you the alarm, okay, and it can be used for R32 and 410A. The only thing you need to consider, I suppose, with both types of leak detection sensors is that it needs to be installed at low level. As I mentioned earlier, R32 will sink, okay, it's heavier than air, so it sinks to the floor. So it needs to be picked up at low level, okay, before it can cool, okay. So these particular semiconductor types do require a separate 12 volt or 24 volt DC power supply, and they require 2-core wiring. It does, as I said, need its own individual power supply in order to be compliant with EN378. The other products, I suppose, on the semiconductor type is that we have the common alarm panel, which I mentioned earlier, which is a 32 or a 64-piece panel, so 32 sensors and 64 sensors, and that requires a 240 volts supply. I won't focus too heavily on this because I know it is specific to Mitsubishi Electric. And the other type is the infrared, okay? And how that works is an air sample is drawn into the device, okay, via plastic tubes, okay, which are attached to the faceplate in the room or the sensor head, okay? And this device shines an infrared beam through the air sample. If that beam is changed as it passes through the air, then a contamination has occurred, and that causes the alarm. It offers higher accuracy, right, as an alarm, but it is a more onerous installation, okay? And it is a more higher equipment cost, but it is there, it is available. And you know, it does give you higher accuracy, which is needed for some applications, you know. So you need to check the application of where you're putting your leak detection in, okay? Again, that has aspirated panels available for them as well. The panel must have an LED and a buzzer alarm indication is on them as well. And then just again on the application guidance, I mean, it does have to be installed at low level. It does require a separate 24 volt DC power supply. You can use it as a standalone, or you can have it wired back to a common alarm panel as well. Again, it needs to be installed 150 mil, as I said, to 200 mil off the floor as well. And there are some guidelines, and there is more guidelines on our website. And I can provide you with more information on all this as well if needs be. The other solution and safety measure is automatic pump down, okay? And for this, you need actuated ball valves, as I mentioned, on the high end and the low pressure refrigerant pipework of each system, okay? So for every outdoor system that you have, you need actuated ball valves on the high and low refrigerant piping, okay? You do also need a pump down panel, and you still need your refrigerant leak detection sensors within the space, okay? That's just another option that we have available. And again, I can send you more information on that as well. So if you are above the threshold, there are safety measures that you can put into place to ensure that you can comply with EN378. So there are some quick links here that is going to be uploaded onto the website as well. So do feel free to download and click into them. And there are a couple of links then on the Mitsubishi Electric R32 solutions as well, should you wish to look at any of the solutions that we have for R32 as well. And that's it. That's all I have. I think we're okay for time. I think I'm bang on. Karen, Declan, you might jump in.
Perfect. Thank you. Thank you very much. You can just go to that last slide, maybe. Margaret. So thank you very much. Yeah, bang on time, really within a minute or so, which is great. And Yeah, so thank you very much, Karen. Very, very informative, very helpful. I know R32 is widely used, and it's probably, if it, as you say, if it has already been installed in places, there are mechanisms for us to check how the charge limit complies with the space available in the application, and certainly your calculator there would be very useful. I know there are others, but that seems to be a really good one. So thank you. So thanks, Margaret, for that. Our next webinar is this day week, next Thursday, the 26th, which happens to be World Refrigeration Day. And we have a great speaker. We have Espen Ronning from the Norwegian HVAC and Refrigeration Association, and he'll be presenting the position paper that the three Norwegian associations have collectively published. It's a 6-page document. It's available on our website and on any Norwegian websites. And really, it's doing the same thing as the IRI. We're trying to encourage the industry to participate, but it's also flagging up a couple of key headline issues, in particular in relation to flammability, ventilated enclosures, and to what extent EN378 complies with ATEX. So that's on next Thursday, the 26th, World Refrigeration Day, World Cooling Day at 1:15. So thank you very much to all our attendees. We have 41 online today, which is fantastic. And thank you. Have a good day, and hopefully see you next week.
Thank you, guys. Thanks so much, everyone, for attending. Thanks, Declan. Thank you. Thanks, guys. Oh, is there a question?